Thanks for coming, all guys. A lot more people than expected. Yeah, so I'm talking to you about Kivy. And the first thing we'd like to do is just kind of show you a video to sort of give you a little bit of context of the kind of things we're talking about. So you have sort of a visual impression of that. So the video is just playing a couple of videos of some installations, applications that have been built with Kivy. There's a couple of mobile applications shown. Some of us have done museum installations, other kind of interactive installations. Usually we have large touchscreens. We've worked with some handicapped children, Connect, Leap Motion, all kinds of different input devices and fun stuff. So I hope that just sort of gave you some sort of impression of what we're talking about when we talk about user interfaces. So we found ourselves in 2013 at PyCon, right? If you think about user interfaces and having made, especially graphical user interfaces, over the past, there's some things that have changed, over the last couple of years. All of a sudden, we have powerful GPUs, everything. Like, my phone has a GPU in it. The Raspberry Pis that we just picked up have hardware-accelerated graphics available. And at the same time, the array of input devices or sensors that we're able to hook up to computers and process has grown just in crazy amounts too. Just if you think about cameras, for example, what you can do with computer vision in terms of interpreting input, if you think about like Connect or Leap Motions or all kinds of other stuff. So that brings with it, though, a couple of issues, which sort of are what motivate the work that we do. For one, when you look at GPUs, they have a fundamentally different way of thinking about computing than like a regular processor, right? Like, most of us are probably used to more like the sequential programming that we learn, and on GPUs, everything happens in parallel. And if you've done OpenGL programming before, even just a couple of years ago, the paradigm was sort of a big state machine, and you sort of push stuff down there, you change some states, draw stuff. That's not how it works today anymore if you really want to take full power of the GPU that you have, and especially when you're talking about mobile devices, it's important that if you want the visual quality and sort of the richness of it, that you make best use of it. That requires, for example, an indirect programming approach, where nowadays if you talk about a GPU, you have to put all the stuff on the GPU to make sure the transfer is actually the slow thing, and make sure it has all the stuff to work on while it's sort of doing its parallel processing. And with the input devices, if you think about multit-touch, it's a much higher bandwidth input method than like a mouse, for example, right? Because you have multiple points. But it increases complexity a lot, because all of a sudden you don't have a simple state machine anymore where at any point you can just check, well, where's my mouse cursor? Because A, you don't know how many there is, you don't know. And there's context, there's information in how long has this one been around in relation to the other one. And so the complexity sort of grows very fast there. And then the last issue that I think we always try to think of is that the composition or authoring of user interfaces, we feel has always been hard. Probably still is, but we'd like that to be a lot easier, because we all want to make really cool looking, working stuff, and maybe we have sort of the idea of, okay, I want it to work this way, and it's like I can see how it works, but all these tools I have, they kind of assume it's supposed to work this and this and this way. So with Kivy, what we try to do is use the full power of the GPU on the platforms that we want to use, but try to keep things in terms of authoring and rendering simple for the programmer who's telling you what to do. Events are a good way to think about user interfaces in terms of input handling. But as with other asynchronous programming, like, it doesn't fit our cognitive model of programming, right? Because we think sort of, okay, like, if this happens with this, blah, 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 and not like, okay, call back here, like, now I'm debugging and I'm like jumping all over the place. And the other thing that inspires us to work on Kivy is sort of like Python in the first place. Like, I mean, we do it in Python. Probably a big part, at least, why we started this is because we didn't want to use another programming language. So we wanted to do this in Python. So like the Zen of Python is in there in the Zen of Kivy, I think, in a way. So for the graphics part, for Kivy, like what the thing that Kivy does for you is, everything that's rendered is hardware accelerated using opengl ES. That means you can do fancy 3D stuff, shaders, you can do really cool visual effects easily, sort of on top of whatever you have already. You can do pixel shaders to add effects or vertex transforms to do like a page curl or something like that, without actually changing anything of what you already have. The way we've implemented it is that all the calling of the GL functionality we've implemented in C and cython, so that we call it from Python. And then I think it was at UDS when we started the Kivy project, when we were there a couple of years ago, someone handed us this paper that a PhD student in France had written about writing a just-in-time graphics compiler. And it sounded really cool, and it actually is pretty cool. So the way that we have it set up is that we have in Cython sort of implemented what we call graphics instructions. So you create these, and the syntax when you create them looks like you're doing sequential programming, like you're saying set the color, draw a rectangle, set the texture, just like before, except we're sort of buffering them all in a display list. But then, since they're instructions and we add contextual information, we can actually analyze that. So we can drop out instructions. Like if you keep setting the color, we don't need to set it again. We just flop them out. And just like a JIT compiler, then you have blocks and you optimize them, and then you only need to change it if it changes. Or if there's a whole bunch of vertex instructions, like just combine them all in one big VBO instead of having 20 different drawing calls. And it also makes the porting easier because we have all the OpenGL stuff sort of implemented there. So as long as we have a platform where we can call GL through C, all the other Python stuff just still works the same way. For the input, like from the very first point before Kivy, we had another framework called PyMT that was sort of an experimentation. Like the main motivation was, okay, like inputs are changing. How does the programming API design, the library design change for this new world that's not based on a mouse and a keyboard anymore? Those things are really good for some things, and you can also do them with Kivy, but there's all this other stuff that we want to be able to do too. So sort of over the years, we've sort of put that in place, and I think we have conceptual sort of tools like and approaches to the way that the input event data is coming in and it is interpreted that makes that stuff easier. So for example, on touch events that are coming in, you can attach data to the actual touch. So like later, if that touch is like, being dispatched and some other widget gets the event or you get it somewhere else, you can look at that data before. So you can sort of keep track of the context of what happened to this touch over time. And then it's also, this guy is just like a crazy, I don't know how he does it, but like it's really nicely designed in terms of architecture in my mind. Like I've learned a lot. Like for the inputs, for example, we have this provider-based design where for each kind of input, there's like an abstract provider. So when we get a new device, all we have to do is like find some way to like get to that data somehow, if it's via Cython or C or Python, and then like push it into the event queue, and then you can read the data in abstract way still, and it works with the application already, but you also have access to like the new information with it. And the same thing is actually done for the way that we do any other like sort of core system interfaces, like for images, font rendering, window providers, video data, audio, camera, all that kind of stuff, where we have an abstract one, and then if you want a new image format, we just need to read it into a buffer. Like, if you can somehow get it into OpenGL, you're done, and you can use like all the other Kivy infrastructure that's there to work with images with it already. And it also sort of allows us to swap out dependencies. Like there's one thing like we can't get to work on iOS. Well, maybe we can find something else that does the same thing, and we just kind of then have to plug it in. So it makes sort of the porting to the different platforms a lot easier. And then, like I said, like there's sort of the Zen of Python, right? Like we've all done import this, I think it is, right? The one other thing that I said in the beginning that sort of bothers us is like, it seems like it's too hard, or harder than it should be, to author and compose user interfaces. Like you think of them as pretty simple things, like sort of what you see, right? You want this here, when you do this, you want that to happen. But you always end up writing all this code to do it, like hooking up event handlers, an event handler here, a different one here, all these different kinds of objects. So what we did is we said, okay, well, we think it should be easier, but like, how? Like in what way? Like if we could just have anything, how would we want to do it? So being Python lovers, we started just like typing and like indenting stuff all the time. So we came up sort of what ended up as a sort of domain-specific language for the composition of widgets or whole UIs, or like how they inlaid. We call it the Kv language. It's indentation-based, so it's declarative. It keeps things concise instead of having to like remember a whole bunch of method names and things like that. And one of the things it does is sort of auto-binding of properties. So if I have a label that has like a text property, if I say, okay, this label, like text, like slider.value, and I have a slider somewhere, like it'll just always be the value of that slider. So if the slider value changes, that value label also changes. I think Qt does something kind of similar in like QML now. And it works really well with graphic instruction because we put the sort of like how does this widget get rendered into this domain-specific language in terms of the graphics instructions, and we can then hook up directly the properties of the widget to the rendering instructions. So let's say you're rendering a rectangle or a circle, and you set the size of it to the size of the widget, and the color to something else. Now, if the size of the widget changes, your rendering instructions change the same way. So you don't have to render all the time and change your rendering methods or keep track of that. It just sort of, like that rectangle will always be that size, and it sort of keeps track, or it does it for you in terms of changing the vertices that it's pushing to the GPU. And the other thing that sort of like in the Python world, we want batteries included. And I think we have that in Kivy in that we've sort of built pretty extensive widget collection of like standard stuff that you'd use and stuff that works with different stuff like the labels, buttons, sliders, different kinds of layouts, transitions between screens, managing screens, some more like specific interactions, like for multit-touch. One of the canonical demos is always like this, zoom and rotate or panning like an image or a map. So we have that implemented in a widget that you can just sort of put other stuff into so it works. And all of them sort of support this wider variety of input modalities instead of just a mouse. Like before, for example, in a toolkit that has maybe technical depth to a time where it's more like just keyboard and mouse, like all their widgets are assuming there's a keyboard and a mouse, and that's it. So you might have something that looks and kind of acts like what you want, except it just works with mouse and not the other stuff. So that's not here, because we've sort of started a little fresher. So I just want to give you a quick demo of that. This is just one of the examples we have in the repository. So this over here is actually Kv language. So here actually, all we have is like one thing, like an RST document widget, and then we set the text property to like something really long, right? Like if it's a French keyboard, man. If I just do this, then all I have is that. There's different kinds of layouts you can, to arrange your things, where they can sort of, so here's a float layout. There's 3 buttons inside of it. You can see the labels on, the text is set. And then the position, and like a size, and like This one says like I want to be like point or 60% of like the thing I'm inside. I'll let him type because I can't talk and type at the same time. But then it just shows some of the other ones. Like there's grid layouts where they automatically arrange themselves in grids. So if you change like the number of columns you're limiting it to, then it arranges that way. I don't know, maybe try the progress bar one. So this shows sort of the auto binding that I was talking about. So what we have is, so it says on the top, box layout, orientation vertical, padding 50. So there's a layout that things get put in after each other. It's vertically arranged, so they go from top to bottom. And there's padding on the side so that they don't go all the way to the other widgets. What did you just do? No, there's only, he's rearranging stuff here. But so then there's a progress bar and 2 sliders, right? And on the slider, the thing in the middle, you can see it says on value, bar value equal to self value, and bar is the progress bar on top. So when the value changes on the slider, this actually sets the value over. So this would be sort of like an event handler in a way, right? Like we do that with the on stuff if something changes. And then just Python code inline. Like wherever you can set a property value, you can just put Python code inline. Another way of doing that would be instead of like if you had on value, like if you take that out here. Yep. So instead of sort of defining an inline function, you can actually tell the progress bar that the value of it should be the slider dot value, like the value of the slider, and you actually get the same effect. Like if you're just mapping properties directly like that, they always stay in sync. And so, and this iterates down, right? Like the last one updates, the slider on the bottom updates the slider in the middle, and because it gets changed, the progress bar gets changed then too, right? If you move the one on the bottom now. Like it just moves the one in the middle, but the other one is still linked, so it keeps changing. Yeah, I don't know. And there's lots of other stuff. I don't think we have too much time to go through all the different demos, but if you guys have more time, we'll be around later too. But so sort of the promise that you get out of it is sort of like this develop once, like run anywhere, right? Like it's always like the holy grail. I'm not sure we don't completely deliver on that, but it runs really well on Linux, OS X, and Windows in terms of desktops. It runs on Android and iOS. We have apps on the market for both of them. Someone just made it work on Amigo. I've had a little bit of work to try to get it to work on the Raspberry Pi. I think Mathieu is really excited now that we just got some free ones. Thank you. But the great thing, like to me, like when I work with it, like for like the work we do in our consulting agency, like I just get to work on my laptop or my desktop, and I have my window, and I just size it to whatever the devices that I'm expecting it to run on, and I run it there. I get to use my normal sort of Python development flow. Like I write something, I sort of try it out. Like Testernight's UI is hard to get complete test coverage at least, right? Because part of it is sort of just how does it feel like, well, maybe I want it over here instead, or I want this a little bigger and stuff. So you end up sort of running it and testing it a lot to get to do that. So I'm going to hand it off to Mathieu, who's going to talk a little bit about Kivy as an organization and some of the other projects that are sort of springing out of Kivy and where all that is going. So I don't know if you want.
Okay. Okay. Is it working? Okay. So hi everyone. Thomas showed us the Kivy framework, so only the GUI part. But it's more than that. I mean, if you want to run your Python code on your mobile, you need a lot of other tools. So we create an organization around Kivy. Right now, we have 7 core developers. We run around 13 public projects. That covers almost everything you can do with Kivy for the mobile. You can get support from 2 mailing lists, one for the user if you have any question, a general question, but if you want to contribute to Kivy, we have another mailing list, Kivy Dev. And if you are not comfortable to vote on mailing lists, we are available like every day on the IRC channels. So, a little bit of history very fast is Thomas started in a University of Iowa to do some research about natural user interface, and he created PyMT. So maybe some of us know about it. It was mainly focused for natural user interface, and basically he wanted to do something with Python, but he had only some idea he wanted to write, so he put it on PyMT. PyMT looked like a big place for experimentation. So if we want to build commercial application or giving something to the user that is stable and well done, PyMT wasn't really done for that. And also we have a big issue is all the graphic power was using direct GL instruction, and that way of doing the thing was not compatible with GLes 2, so we cannot run PyMT on mobile device. So we redesigned all the graphic power and the API, we clean everything, and Kivy was born in UDS in 2010. So as I say, we renamed API, we built a new graphics, and during 2011 we had the support for Android and iOS. So for building, you can actually today write your Python application, run it on desktop, but if you want to run Python on Android and iOS, means you need to have the Python interpreter on it. It's not the same architecture, so you need to cross-compile the Python and also all the sub-library, like SDL, LXML, SQLite, etc. And it's kind of complex if you want to do it yourself. So we created two projects. The first one is Python for Android. It allows you to cross-compile Python and many other libraries first, and then we have another tool within Python for Android that allows you to take your code application, take the library you just compile, and create an APK. This is a package name for Android. So be warned, there is two Python for Android projects. If you search on Google, you will have two results. Our Python for Android is located at github/Kivy. The other one is commonly named, it's P4A, right? Okay. And there is another toolchain we provide for iOS, so it's Kivy iOS, but it's not designed as the same as Python for Android. So it's not modular, you cannot really add the library you want. We need to redesign this project. And why we don't merge both of them is because on Android we are loading the library dynamically, but on iOS it's forbidden. So what we do on Kivy iOS is each library, Python, SDL, SQLite, Kivy, is compiled as a static library, and then we merge everything into one binary executable that runs on the iPad and executes your application. So because it can be hard to understand everything, we started a new project. So it's still a work in progress. It's called Buildozer. It's like one tool to run them all. The idea is you have one specification file called buildozer.spec. And with one line of command line, you will automatically compile your application, install everything you need. Like for Android, you need to download the SDK, the NDK, prepare all your computer to be able to do Android application. It can be hard for newbie. Buildozer will do everything for you. It will compile, install, create the APK, deploy on your device, run it on the device, and you have even the possibility to debug it, have the log on your device. And it works also on the iPad without Xcode. Only the same command lines. So it hides the complexity of packaging. For an example, this is a spec file. So the title, the package name, where the source of your application is, the version, the requirements, the icon, the press splash, that is common for Android, iOS, and even on desktop. I mean, if you package to Windows, you want the same things. So this is why we did Buildozer. And also we have some tags for specific thing, a specific platform. Tags like Android.permission, it doesn't exist on iOS. And on iOS, if you want to sign, you need the name of your key in the key chain. So you can specify everything in here. Okay? So just you have Kivy if you want to do your application, graphic application. Then we provide toolchain to be able to run Python on mobile. But we are missing one thing: is how can I access to my GPS, to my SMS, my contact, my accelerometer? And we are in Python, but on Android, all the API for the mobile is in Java. On iOS, all the API is in Objective-C. We are in Python. How can we do it? So on other toolkits, they do an abstraction for that. But right now, we don't do anything for that. We think more about a generic way to approach this problem. So we created 2 other projects. The first one is PyGenius. This is a library you can just import and access to any Java class from Python. So you wrote Python and you can access to Java API. And we started to do the same for Objective-C. It's called POBGIS. Here is an example, like I want to say something from my phone. So I import Genius, in auto class, how can I say? It's like importing the definition of a Java class into Python, and then I'm just using it. Like, it's very easy to understand. Okay. And another example is if I want to access to the GPS of my phone, the Android API, how can I say, require you to create a Java class that implements one method. So we started another work is to be able to implement Java class from Python. And it looked like that. So you create a GPS listener and you say, this Python class will mimic the interface of the location listener in Android. And then you implement one method called onLocationChange, and you got it. So from now, it's not really working right now. I'm still in the last part, but in the next week, we will be able to release everything. Okay, 2 more slides. We got funded by PSF last year, so we got $5,000 to be able to port Kivy and all the projects we showed to Python 3. It's still in process, but we want to thank you, PSF, for that, because it's a big relief. And last week, I started funding for running Kivy on Raspberry Pi. And I just asked for $600. We got funded in 5 days. It was really amazing. So for everyone who support us, I would like to personally say thank you. And the next step is to get $1,000 for using the work we did for the Raspberry Pi to improve the Windows platform. That's all. Okay? So thank you, everyone, and I hope you enjoyed the talk.